In this lesson, we're going to go over how to 3D model the Titan 9M. Let's first take a look at our blueprint and see what we're working with. Sheet number 1, we have a series of circles. Notice that our datum location is in the center of this particular circle here. The 4 circles on the outside have a diameter of 750 thousandths. You have another circle here that is tangent to the outside circles, and this one is at 600 thousandths. We have this very large circle on the outside of our part. That one is 1 inch 900 thousandths. We have a 1 inch 50 thousandths circle that is going to go through and create this bore here. And then lastly, we have these tangent lines, and these lines are going to be tangent to a 1 inch diameter circle. After we create our basic shape, we're going to extrude it 750 thousandths. Moving on to sheet number 2. Sheet number 2, we did this like revolve cut around this part. And that revolve cut actually gave us these little tabs in which some counterbored holes are located on. And then sheet number 3, we have these pockets. These particular pockets do not have a flat bottom on them. It actually follows the profile of the part. So let's jump over to Fusion 360 and create this part. I'm over here in Fusion 360, and very first thing that we're going to land is some circles. The very first circle that we're going to land is going to be on our datum location. I'm going to go C on the keyboard for circle. We have our triad here with our 3 different planes that we can draw on. We're going to choose this plane, which is our top plane. We're going to start from the center where our origin is. I'm going to draw out our circle. And this circle has a diameter of 750 thousandths. I'm going to repeat this right underneath, C for circle, 750 thousandths, and enter. Now these 2 circles have a relationship. The center of them are perfectly vertical to each other. So I'm going to go up to constraints and down to vertical. And I'm going to click on the center of our circles, adding in a vertical constraint. These circles also have a dimension between them. We're going to go to D on the keyboard for dimensions. We're going to click on the centers of these circles and draw our mouse over to the left, and then click, and then type in 1 inch 150 thousandths. Notice that our geometry is turned black in color, indicating that it is fully defined. Now that we have these circles, I'm going to place the 3 circles here in the center. The first one is 1 inch 900 thousandths. The second one, coming right off the same axis, it's going to be concentric, is 1 inch 50 thousandths. And then the third one here, again making it concentric, is 1 inch. After you make the 1 inch circle, we're going to change this to a construction circle by clicking on it and pressing X on the keyboard. Or you can also choose the construction icon out of our sketch palette. The center location of this circles, or the set of circles here, has a dimension, 2 dimensions driving it. We're going to set that right now. So the center to our origin. This has a horizontal measurement of 2 inches, 625 thousandths. And then it also has a vertical measurement of 575 thousandths. Notice as soon as I lock that into place, everything turns black, meaning it is fully constrained. And now we're ready to land our lines in. We're going to go L on the keyboard. First line I'm going to do is we're going to land this kind of right up here in this area. Notice that that line is not attached to anything. It's an arbitrary length. I'm going to show you there's 2 different ways to draw a line and constrain it. So right now, again, we just have a line. It's arbitrarily in length, and then we're going to add some constraints to it. We're going to go to our toolbar where it says constraints and go down to the tangent constraint. We're saying that the line, we're going to click on the line, and this circle are perfectly tangent to each other. And I'm going to move this line up a little bit. And then we're going to say that this line and our construction line are tangent to each other. The reason why I moved this up is Fusion 360 has kind of the ability to, when you're adding constraints, it may add the constraint down to the bottom here, and that's not what I wanted. So I just moved it up kind of closer to the location I wanted it to be. Afterwards, we're going to go to constraints, and we're going to go to coincident. The endpoint of this line is coincident to the perimeter of our circle. And then lastly, the endpoint of this line is coincident to the perimeter of this circle. So that's the hard way to do it. The easy way to do it is Fusion 360 has some mouse gestures that you can use. We're going to go back to L on the keyboard for line. We want our line to come off of this circle and then be tangent to this circle over here. So what I'm going to do is I'm actually going to left click on the perimeter of our circle here, kind of on the opposite side of where I think the line is going to be tangent from. I'm going to left click and hold that left click down, and I'm going to move my mouse around. And notice Fusion 360 has already put a coincident and a tangent constraint there on that circle for me. I'm going to use my mouse wheel here, and I'm going to zoom in to the construction circle, and I'm going to move my mouse on the perimeter of it until I see the tangent constraint appear. As soon as I see it appear, I'm going to release my mouse. So there it is. And it added another tangent and another coincident constraint for me. While I'm here, I'm going to add in a construction line going right from the origin of these three sets of circles here. And I'm going to draw this construction line perfectly vertical down, adding an automatic constraint. If it doesn't add that automatic constraint in, you can always add it later. Afterwards, I'm going to change this to a construction line by pressing X on the keyboard and clicking on the mouse, or clicking on the line. Next, we're almost done with the geometry here. We need a 600,000 circle over in this area. So C on the keyboard. I'm going to type in my measurement of 600 thousandths. This circle is tangent to the outsides of these two circles. We're going to add in our tangent constraint to both of those circles. Now that we've got one side done, we're just going to mirror all the geometry to the other side. We're going to go to Create and down to Mirror. The objects that I want to mirror are all the geometries here, including all of the constraints. So I'm going to left click and hold down my mouse, giving me a selection box. I'm going to select everything that has to do with those circles. And then I'm individually going to click on the lines here. Notice there's 11 objects selected. I'm going to select my mirror line in my pop-up window and then choose this vertical line that we created as a construction line. As soon as we did that, it replicated all the geometry on the other side of the part for us, and we can press OK. Now that we have all of our geometry in place, we're going to right click and go to press and pull. Well, we want to press and pull essentially the entire geometry. So I'm going to come in, give me a selection box just like this. And then I'm going to disregard some of the geometry. I'm going to come back in after the fact and click on the geometry I do not want to select. And that includes this little kind of like tooth-shaped geometry in our bore on both sides. So we have our geometry selected now. You should have 10 items in total. And the distance we're going to extrude this part is 750 thousandths. And we're going to press OK. Notice we have our solid body now. We're almost done with page number 1. Page number 1, the last thing we're going to do is this vertical line on all 4 corners has a small radius to it. We're going to go to Modify and down to Fillet. We're going to select all 4 of those vertical lines. And the dimension for that fillet is 300 thousandths. So I'm going to type in 300 thousandths and then enter on the keyboard. Sheet number 1 is done. Moving on to sheet number 2. Sheet number 2 has this revolve cut around it. To set us up for this revolve cut, we're going to put some construction geometry in. We're going to go L on the keyboard for line. We're going to click on the top of the part here. Be mindful you are not clicking on these planes over here. So click on the top of the part. We're going to go concentric to the bore here and go straight up with this line. There's really no necessary dimension for this line. It's an arbitrary length. And then we're going to change this line to a construction line by clicking on it and pressing X. Afterwards, we're going to finish our sketch, go to our toolbar where it says Construct, and go to Plane Along Path. You're going to select this line as our path, and you are going to set your distance to 0, and that will position our plane exactly in the center of our bore on our part. Now, if you made a mistake and this line does not have a vertical constraint on it, that will potentially affect your revolve cut. So make sure that this line has a vertical constraint on it. Afterwards, press OK. Now we have this plane precisely in the center of our part. We're going to create a new sketch, but this time the sketch is not going to be on the top of our part, and it's not going to be on those other planes over here. It's going to be on this construction plane that we just created. So L on the keyboard. We're going to click on the construction plane, and notice how it's kind of grayed out here. We're going to left click on it. We're going to anchor it right to this origin here on the top of our part and drag an arbitrarily length line all the way over to the end of our part. And make sure that this line extends over the top of the part. Otherwise, you may have some errors where the part doesn't cut all the way out. Next, we're going to draw a vertical line coming off of it. And then we're going to draw another horizontal line coming back onto the part. And then an angled line coming up to our original line. Be mindful of these other vertical lines here, that you stay away from those, because Fusion 360 will add an automatic constraint there, and it will actually project that geometry onto this particular plane, and we don't want that. So we're just going to put in an angled line here. We'll get out of our line mode, and then now we're going to add some dimensions. D on the keyboard. This line over here, according to our print, is 250 thousandths tall. And then from our datum location to this first point where our angled line is at, this line is at 688 thousandths. And notice how it snapped that into place for us. And then the point on the bottom of that angled line to our datum is 1 inch, 621 thousandths. And then enter on the keyboard. Now that we've got our lines dimensioned, at the bottom of this intersection here, there's a small little fillet. We're going to go to Modify and down to Fillet. We're going to click on that corner there, giving us a fillet, and we're going to type in 500 thousandths and then enter on the keyboard. I'm going to turn my body off so you guys can check out the sketch that you just created. It's a pretty simple sketch. Just a couple lines here with a small little fillet. And what we're going to do now is we're going to revolve this sketch around, kind of like a lawnmower blade, and it's going to cut away anything in its path. But to do this, we need to put in a temporary axis inside of our bore here. We're going to finish our sketch, go to construct, and then axis through cylinder. And the cylinder that we're going to choose is this bore. And notice the teal construction line that it just put in for us. That is our new axis. And then press OK. Now that we've got everything in place, we're going to go to Create in our toolbar and down to Revolve. And notice on the pop-up window here, it says you're going to revolve a sketch profile around a selected axis. And that's exactly what we're going to do. The profile that we're going to revolve is our sketch. So I'm going to click on the sketch here, and it should turn blue. Then I'm going to select my axis as that temporary axis. And we want this to revolve cut 360 degrees and press OK. Afterwards, I'm going to turn the visibility of my construction axis off by turning off the eyeball there. And then I'm going to turn the visibility of this sketch off also by clicking the eyeball on it. Our part's looking pretty good. Almost done with sheet number 2. Last thing on sheet number 2 is we need to create some counterbored holes on these tabs. But to do this, we have to land some locations here first. Well, we're going to go and turn sketch number 1 back on. And notice we have some center locations here from our original sketch. So the only thing that we're going to do is we're going to project those center locations onto the top of our tabs. I'm going to turn sketch number 1 back off temporarily and then create a new sketch on top of the tabs here. I'm going to turn sketch number 1 back on and then P on the keyboard for project. And I'm going to choose the center locations of each one of those circles and then press OK. Actually, sorry. And then in addition to that, to kind of prepare for our pocket, actually we're not going to do that right now. So, excuse me. So we're going to choose those 4 locations and then press OK. And then we're going to turn our sketch number 1 back off. Now we have those 4 locations. We're going to go H on the keyboard for hole. That is the shortcut. You can always go to create and down to hole. We're going to choose those 4 locations. And then we're going to fill out our pop-up window according to our print. According to our print, these holes go all the way through the part. They are going to be counterbored. There are no threads in it, so that it is considered a simple hole. The diameter of our counterbore is 380 thousandths. The depth of our counterbore is 250 thousandths. And then the diameter of the hole itself is 250 thousandths. And then press OK. Now you can see we have those holes going all the way through our part. and its counterbored for a socket cap screw to go into. We're done with sheet number 2 here, and moving on to sheet number 3. Sheet number 3's got these pockets on here. The way that this works is kind of interesting. We're going to create a sketch on top of our part here, right on this ring here that I just clicked on. So let's do that now. Create sketch, and you're going to click on that ring. We're going to go back and turn the visibility of sketch number 1 back on. We're going to project our geometry from sketch number 1 of these circles here to our new sketch. So I'm going to click on the outside perimeter of our circles. And then lastly, we're going to project this larger diameter circle. That's the one that I thought we were going to project earlier, but I was getting ahead of myself. So we're going to project this 1 inch 900,000 circle here, and then press OK. Afterwards, you can turn the visibility of sketch number 1 off, and we have geometry for sketch number 5 now. I'm going to put in some lines now to make up our pocket, so L on the keyboard. I'm going to draw my lines in here, just like this. And I could do the same over here. This example here, we're actually going to mirror this as some features. So we can actually disregard these sides. I can come over here and delete those projected circles because they're actually going to be kind of redundant for us. According to the print, this line and the outside of our part on both sides are perfectly parallel to each other. So I'm going to go to Constraints and down to the Parallel constraint. We're going to click on our line and then the outside of our part. And sometimes Fusion will automatically project that line, and right now, for whatever reason, Fusion's not projecting it. Let me see if I can get the other side to work. If it does not project for you automatically, you can force it to project by going to P on the keyboard, and we're just going to click on those lines manually. Now that we have those projected links there, we're going to add in our constraints, just like that. We have some other constraints here. We're going to make the endpoint of this line coincident to the circle on both sides. So we're going to go to Constraints down to Coincident, and from our endpoint to our circle, and our endpoint to our circle, and we're going to do that on both sides. Afterwards, we're going to add a dimension between these. We're going to go from our new line to the outside of our part, and that dimension is 150 thousandths. And we're going to repeat that on the other side. Lastly, there's a circle over in this area here, so C on the keyboard. This circle's got a diameter of 651 thousandths. And then it is also going to be tangent to these other two 750 thousandth circles. So I'm going to go tangent from the outside to that circle and the outside to that circle. I'm going to trim the extra away here by T on the keyboard and then click on that extra, and then now we have that arc fitting in between them. Now that I have my geometry in place, I'm going to right click and press and pull. The area in which I'm going to press and pull is this area. I'm going to click on it, and I'm going to orbit my part here so you guys can see something. If I was to simply just drag my mouse down and type in a measurement, notice the bottom of my pocket is going to be flat on here. I want the bottom of my pocket to follow this contour here. So in our pop-up window here, where it says extent, we are going to choose to object. And the object that we are going to extend to is this contour. Notice we popped up an error here. That's okay. The only thing that we need to do is we need to chain our faces. And then our offset is going to be the distance of our pocket, or the depth of our pocket. So I'm going to type in negative 325 thousandths. And Fusion 360 automatically knows we're cutting. And then notice now that our pocket is following the outside of that contour. So take a second, fill out your pop-up window here and make sure it all corresponds to mine. Afterwards, press OK. And if you orbit your part around, you can actually see that that follows that contour on the outside of our part. Almost done with this particular pocket. We have some corner radiuses that we're going to add in. So modify down to fillet. We're going to click on these vertical lines first. There's 4 of them in total. And I'm just orbiting my part around so I can see all of those lines. And the distance of those radius is 255 thousandths. And then press OK on the keyboard. Almost done with this pocket. The bottom profile of this pocket has a radius to it also. This radius would be cut in using a ball end mill. We're going to go back to fillet, and we're going to click on the bottom of that profile now. And according to our print, this has a radius to it at 250 thousandths. And that can be seen in the section view, which is our front view. And then press Enter on the keyboard. Now we have our pocket. Now what we want to do is we want to mirror all this geometry that we just created over to the other side. We're going to do this very similarly to how we created our revolve sketch. We're going to create a line on top of the part again. So L on the keyboard, we're going to click right on the top of the part. This time we're going to click in the center of our bore, so make sure it's concentric, and then drag a horizontal line off the top of the part and make sure it's got a horizontal constraint on it. If Fusion 360 doesn't add it automatically, make sure you come down and add that constraint in manually. Afterwards, change that line to a construction line by clicking on it and pressing X on the keyboard. We're going to finish our sketch and then go to Construct and down to Plane Along Path again. We're going to set our distance to 0. And then it precisely set that plane in the center of our bore. If I turn my original plane on, notice that these planes are perpendicular to each other. That's why I couldn't reuse the original plane. I'm going to turn sketch number 6 off, which is that line. And then I'm going to go to Create and down to Mirror, because we're going to mirror all these entities over. The pattern type, we're going to use features. And we're going to go down to our history markers down in the bottom left-hand corner. And we're going to select all of the features that make up that pocket. So the extrude and these two fillets. In our pop-up window, we're going to select our mirror plane, which is that construction plane that we just created, and then press OK. Now, if you're having any types of issues mirroring this across, you may want to play around with your compute options. Sometimes Fusion 360 doesn't like optimize or identical. So you can play around with these if you're having any types of issues where it's not actually creating those features for you. Afterwards, we're going to turn off our plane. There's one last major feature that we need to add in. If you look at the front view, front section view, there's actually a bore, like a big counter bore in here. So we're going to add that in. C on the keyboard. We're going to click on the top of the part. We're going to go concentric again and drag our circle out. This circle is 1 inch 250 thousandths in diameter, and then press enter. Now we're going to right click and press and pull. The area in which we're pressing and pulling is this blue area here. According to the print, that's going to go down 500 thousandths, and then press OK. And notice we have our counter bore. I always save my chamfers for the end. We're going to come in and we're going to break all these sharp edges. If you look at the front view of our print, it says the edge that's going around the perimeter, the top perimeter here, is 25 thousandths. So we're going to add that in right now. So modify and down to chamfer. We're going to click on the outside profile here, and then the tops of our pockets, because there's a quantity of 3 there, so I'm assuming that the outside and the tops of our pockets all have that measurement. And our distance is 25 thousandths. And press enter. And then lastly, we're going to break the remaining balance of sharp edges on our part to 10 thousandths of an inch. So modify, back to chamfer. We're going to click on the top of this bore, the tops of our holes, the bottom of our part, the bottom of our holes, and we're going to break those at 10 thousandths of an inch. This is a good opportunity. Double check your part. Make sure it follows our print. And this concludes the tutorial on how to 3D model the Titan 9M.